We are talking the topic of arc length and area of a sector today. You were introduced to arc length and area of a sector in geometry. So you've seen these concepts before. What you haven't seen is the formula that is way nicer now that we know what radians are and how to find them. So we get a lot simplified version of those formulas than you did in geometry. Real quick reminder on circle information. Remember that your radius from a circle is any segment that goes from the center of the circle to the edge of the circle. A central angle is any angle that is formed by two radii, or an angle whose vertex is at the center of the circle. That an arc is just that crust on the edge of the pie here. So if we were to talk just that crust right there, just that little piece of the circumference, that is what's called an arc in a circle. And if we want to talk about the sector of a circle, it would be filling in that pie piece. So this is a sector when we fill in our piece of pie. Area versus plane lengths for arc length. You are going to be given formulas for finding arc length and finding area of a sector. They are not formulas that need to be memorized. You just know how to use them. You'll always be given those formulas. You just have to know what goes where and how to appropriately use them. So first one, formula for arc length. Again, doesn't have to be memorized, just has to be understood. I don't know why your book uses the letter S for arc length, but it does. Okay, I usually put the word length or arc there, so that's not a big deal, but it is just the length of the radius times the central angle. This is what people are going to make a mistake on. By far the biggest mistake that will happen on this quiz is that we do not put the angle in the correct format. It has to be in radians, and over half your problems they're going to hand you the problem in degrees. So our job will be to convert it to radians, like we learned how to do, and then put that angle in there. So let's do a very basic example to start with. Find the length of the intercepted arc. That's just a fancy way for saying the arc that is inside that angle. Find the length of the intercepted arc in a circle with a central angle measure of pi over 3 and a radius of 4 inches. Round to the nearest tenth. Have a lot of people say, well, how can I tell if the angle is in radians or degrees? If it does not have a degree symbol, it is not in degrees. Pi is not the indication. We're going to see several examples today where radians is not in terms of pi, and that's fine. It doesn't have to be. A lot of times it is. But there is no degree symbol, which means this angle is in radians. That is theta, pi over 3. They tell us that it has a radius of 4 inches. So in our arc length formula, that is just the radius times theta, we have the radius and theta. So we just put those into our formula. Pi over, let's say 4 times pi over 3. And it asks us to round to the nearest tenth. So then I just grab my calculator. We actually do type in pi because it says round. Okay, so go ahead and type in pi when we do this. Yeah, that's not really a conversion that's going to happen from different feet to inches or something. McGuire, will you type in the 4 times pi over 3 and round to 1 decimal for me? Very good. And when we're talking arc length, it is just a length that we could measure like with our ruler. So it is in plane units, 4.2 inches. All right. This is where we're going to see more of our problems lie. Given a circle with a radius of 10, find the length of the arc intercepted by an angle of 30 degrees. Okay. This is, again, our arc length formula. Arc equals our radius times theta, and this is, if I were thinking about your quiz that you guys are going to take on Monday, the number one mistake. And people are going to say 10 times 30. The answer is 300. And I just told you that's wrong. What did I do wrong? It's not in radians. We just get going too quickly and throw numbers that we see into the formula. You have to start this one by converting to radians. One of the things you are responsible for is knowing how to convert. That is not a formula that is given to you. Remember that the converting always ends up being pi and 180. We just have to remember what goes where. When we are going from degrees to radians, we want the pi to be in the top. So I would take 30 divided by 180, simplify that fraction. Simplifies down to what? 30, 1/6. So theta is pi over 6. Okay, go ahead and type that in your calculator. Round to your nearest tenth. 180, divide. The 180 is in the bottom, so under that bar means to divide by 180. Seth, can you type that in? 10 times pi over 6 and round to your nearest tenth? Any questions? Right here. This is number 1 mistake. I'll show you number 2 mistake in just a second. Okay. Look for the degrees. They're going to happen all the time on these problems. Okay, on this one, given a circle with a radius of 5, find the length of the units we need it to be in. So I just fill those numbers in. 5 times 3. I put this very simple example up here because it bothers people that it's just 3 radians, but it is. 5 times 3 is 15. Any questions? Yes. Okay, this one is probably the second most missed problem, maybe the most missed problem, and that is this. It says a central angle in theta in a circle of radius of 4 meters is subtended. That's a fancy word, don't let that distract you. No different than what we've been looking at. By an arc length of 6 meters, find the measure of theta. So solving our equation for theta. So there's our equation. They tell us that it has a radius of 4. They tell us it has an arc length of 6. The question is, what is theta? So put those numbers in the right places here. Radius of 4, arc length of 6, and we're supposed to solve for theta. Well, don't overthink the solving process. What do? Divide by 4. They asked us to give our answer in radians, and they asked us to give our answer in degrees. Our answer is 3 over 2. Which one is that? Radians, right? And again, this is going to bother people because it doesn't have a pi. Guys, I don't care. Radians don't have to have a pi. I don't do anything to that. When it says theta equals, the label is always radians, right? As is. It is just 3 over 2. So that's one of the answers they asked us for in radians. To get from here to here, now I do need to convert the same way I have converted everything that is in radians to degrees, and that is by multiplying by 180 over pi. Now, usually that meant I got to cross off my pi's, right? But our radian measure didn't have a pi in it, so I'm just going to have to type it all in my calculator and get an ugly decimal. Round to our nearest tenth. Kenzie, when you have that typed in, I'll take that from you. I think I did, but that's okay. 85.9, 86. I didn't have directions up there, so. Okay, this is it. This is what people are going to mess up. They're going to want to change that somehow. It is just 3 over 2. Okay, and that is your measure in radians. 1.5 radii along our circle. Okay, all right. Moving on to our other formula. Again, not needing to be memorized, just needing to be understood. The area of your sector. Now we're filling in that piece of pizza or that piece of pie that's in there. We're filling it in. The area of it is 1/2 times the radius squared times our central angle theta. that again must be in radians. So just like we saw in our arc length, they will hand us that angle in degrees a lot of times, and we'll have to convert. Or they might ask us for our answer for theta, and we have to convert it to whatever format they ask us for, but paying attention to that unit right there. Has to be in radians. All right, anyone still need this page? Okay, so going through a couple examples of our area of a sector. Find the area of the sector with a central angle of 3 radians and a circle of radius 12. So again, going to our formula, what do we need here? Area equals 1/2 times our radius squared times theta. They tell us theta, and we're looking for that keyword of radians. And it is, theta is in radians, and they give us the radius is 12. Putting those into the right places here, 1/2 times 12 squared times 3. Nick Peterson, when you have that typed in, I will take that from you. And he caught the label. We have now switched to area, so it is in meters squared. Very good. Questions on that? So that one's just a straightforward, put them in the right place in my formula, type it into my calculator. So let's look at some other versions that are not as straightforward. A sector of a circle of radius 22 has an area of 310 square meters. Find the central angle of the sector. So on this one, the question mark is, what is theta, right? In our formula, they tell us the area is 310. They tell us the radius is 22. The question again is, what is theta? So we'll solve that eventually for theta. Put those numbers in there, and then we need to talk order of operations here. You either need to type this in exactly as I have it written up here in your calculator, or remember that exponents come first, right? Exponents are before multiply, so I need to do the 22 squared and then times 1/2 or divided by 2. Brogan, can you do that for me? 22 squared divided by 2. Okay, solve for theta. Michael, can you do the 310 divided by 242 for me? Okay, now this is an incredibly important question. 1.28 what? What would I label that number? Radians. It's theta, right? And if I just got theta out of my equation, it is in radians. And so on a question like this, we would pay attention to, maybe it's followed up with find the central angle of the sector in radians. Our answer is 1.28. If they change that to in degrees, we now have to convert 1.28 times 180 over pi to get my answer in degrees. Okay? Any questions on that? I don't really care. Usually you'd see it in a fraction, but all right, last one. Sector of a circle with a central angle of 45 degrees has an area of 39.3 square meters. Find the radius of the circle. So again, we are solving for something in here. Area equals 1/2 r squared theta. They tell us the area is 39.3. They tell us that theta is 45 degrees. We are solving for r. Please stop me before I do something wrong here. Right? I cannot put 45 in there. That's, again, going to be our number one thing. If I see that degree symbol, immediately convert to radians. So the correct number that I should put in for theta, what is 45 over 180 to simplify down to? Pi over 4. And again, we got to be looking for that. It's going to happen all the time. They're going to tell you the degrees angle. We need to convert because this formula is not set up to convert for us like it was back in geometry. Okay. I can multiply those together. I don't really care how you go about solving this as long as everything you do is a legal maneuver. We could multiply by 2 to get that 1/2 out of there. I went ahead and just took 1/2 times pi over 4, multiply straight across the top, straight across the bottom, and got pi over 8. And then I would divide both sides by pi over 8 or multiply by its reciprocal, which I think comes out to 100 point something. 0.8. And then when we square root it, it looks even nicer, right? Because even when I round it, it rounds to like 10. Okay. Any questions on that? Everything is in radians. What we put in needs to be in radians. What we get out needs to be in radians, right? Just keep that in mind when you are doing these formulas. Your assignment tonight is out of the book. I will leave this up here, but you guys have a homework quiz